Good morning to all the distinguished guests and speakers in the audience, along with the MVI events for organizing the conclave. I was just discussing with Jennifer, and uh, she asked me to start with this. I heard somewhere that India is a land of mouth-watering opportunities and eye-watering challenges. So, on the same lines, we just heard from our previous speakers as well that as oil and gas continues to get deeper in offshore, the paramount importance today is that how do we answer two questions with regards to this. First is that get the operational cost down and increase the production wherever you can. So these are the two questions that we'll be focusing upon in the presentation as well by some of the techniques that we'll be showcasing. Of course, there's a lot more, but predominantly these are the two questions, and the answers lie in technology and automation. Now, you know, uh, the offshore and deepwater oil exploration industry has undergone quite a significant advancement in the recent years. And as I said, how to reduce the well cost and how to increase production and where discoveries are made overall will be the questions to answer while keeping emissions at a minimum. So, this is the need of the hour as well, along with the first two questions, because yesterday I saw 1.5-degree target seems difficult. So the only way that we can try to somehow achieve it is by keeping our emissions lower while meeting our production targets, and of course the operational costs needs to remain within the budgets. Now, both technology and automation play a very crucial role in improving efficiency, safety, and the overall operational outcomes. Now, the entire industry explores, or rather is exploring various ways, and some of the techniques that I can think of are, data collection and analysis, preventive and predictive maintenance, robotics, and of course, remote operations. So, sir was talking, regarding seismic, and we'll come to that a little bit as well. Now, highly efficient tools and equipment are also one part of the puzzle, which can help us achieve our targets, which we discussed earlier. So, for instance, drill bits that can drill through layered formations. For instance, I'm a drilling guy, so that's why. And tools that can help us do operations in runs fewer than the ones that are earlier required. For instance, one of the technologies that we are seeing on the slide right now. Now, this technology in particular for offshore and deep water environments where you have uh, narrower mud windows, mud losses, or things like basically complex hole situations, we need technologies such as this to ensure that we are able to do the job in lesser than required runs, reducing overall operational cost, and of course saving risks of losing wells while we are drilling in the offshore. Now, besides these technologies, as I said earlier, automation has a big role to play in for us to achieve what we've set out for. So, subsurface data collection and analysis in the realm of offshore oil exploration, the collection and analysis of vast amounts of data, this is paramount. Technological advancements have revolutionized this aspect, enabling more accurate and real-time data acquisition. Seismic surveys, advanced geomechanics modeling, all these are planning phase. So, for us to do this, it means that we can predict the issues that we might face while we are actually conducting operations and take our steps required to try and avoid them or at least mitigate them if we do face them. Now, the flow diagram you see on the screens here, this is what we are doing within Baker Hughes. So we are starting off at well planning stage with machine learning algorithms, which are doing their job in terms of digital twin, which is a product of ours, which helps us plan wells or plan trajectories while on the go. Now, it is bringing the digital and the virtual together environments. Now, the second part is taking the digital twin and uh, e-file and running it while we are executing to continue the operations on the rig side to make the file take decisions on our behalf in times lower than required. And the third part is, of course, done by the sensors, which is the data stream, which actually collects data, transmits it, and continues the process again and again and again. So overall, using the same digital automation techniques, we have already onboarded or are onboarding more than 60 plus customers worldwide. We have drilled more than 9 million feet, which is about 3 million meters of footage using the digital automation services worldwide. And this is a huge testament, as far as our commitment along with the customer's commitment go towards, achieving our three targets, which is increased production, reduced well cost, and of course, reduced emissions. So this is how it works. Now, some of the drivers and growing interest towards automation are for reduction in drilling runs and decision time, of course. This example in particular talks of the latest in that we as an industry are trying to do, which is reservoir navigation automation. I understand currently the exploration scope exists, and we as far as reservoir navigation goes, go towards increase in production, but that is one of our key targets, the second one which we just discussed. So how does that work out? How do we automate? What are the features of automation? The first is downhole automation, which is acquired by the tools that we put downhole, all the robust, intelligent electronics that goes in the hole and collects data for us to take decisions based upon. The second is surface automation, which is mostly executed at the site. Here we have the scripts running on the site servers, and the users can sit remotely. The third is the drilling optimization, wherein we advise the employees supplementing their decision making. And the final puzzle piece is the artificial intelligence and machine learning algorithms, which have become indispensable tools for optimizing offshore oil exploration and eventually production as well. These technologies are employed in the various stages of the exploration process, ranging from reservoir modeling, as we discussed earlier, to drilling operations. Now, machine learning algorithms can analyze and learn from vast data sets, becoming smarter as you use them. In fact, if I just type in it is so great that if I just type in a topic within Chat GPT today, it can write an essay on it, and you can pretty much learn on the go. So that's how amazing and smart and fast things have become. The final, what I just discussed, is the reservoir navigation automation, which is predominantly targeted at reducing decision-making time, especially when you're drilling in expensive offshore deepwater environments. The current oil pricing and resource current scenario, this is very important because offshore sites now go for a premium on a day-to-day rates. It's very expensive to have a day of offshore operations, and even more expensive if you have non-productive time or time taken to take decisions during the same day. So this is just a statistic of what we have done recently. By utilizing the reservoir navigation, we have actually been able to reduce decision-making time by something like 7 to 10 minutes from 13 minutes. So majority of the time is saved in the determination of boundary positions, in the determination of data with regards to what is the decision supposed to be taken next. Now, for extremely long sections, you would on an average take 50 to 80 decisions. Now you multiply that by 10 minutes, and that's the amount of time you look at saving. And of course, that gives you improved average overall rate of penetration, along with avoiding hole issues which you might have, if you are continuing to be in the same spot while you are continuing drilling. Now, this is a snapshot from one of the shadow wells where we have actually run the automated RNS system. Now, if you see my apologies. If you see the orange, okay, never mind. Okay, if you see the orange curve on the top, that is wait, just a second. Yeah, okay. If you see the orange curve on the top, that is manual navigation, and the yellow curve on the bottom is automated navigation. So there are places where it is very visible to see that the yellow curve responds actually faster than the orange curve, which basically means that you are doing a improved job at a faster time than you would be expecting to do. This 3D visualization, it clearly illustrates the potential value that you gain by using the automation system to steer closer to the well objectives, of course. Further developments that we have ongoing, which will see the reservoir navigation systems to be directly linked to our proprietary automation systems, ultimately aiming to deliver a decision time of close to 1 minute. Now, of course, cloud computing and big data analytics also has a part to play here, which we must ensure to enable efficient storage, processing, and interpretation of the collected data. So, by deploying advanced algorithms, oil exploration and the related companies can identify patterns, anomalies, and potential reservoirs with great accuracy and speed. Now, if we talk numbers, we have about been able to deliver more than 200,000 feet till 2021 year end. We have had ROP improvements, rate of penetration improvements of up to 200 feet per hour. We have had more than 370 days in rig operations saved. We have drilled average sections lengths of more than 20,000 feet, and the longest section that we have drilled using reservoir navigation automation is to 27,000 feet. In conclusion, we feel the future is exciting with the new developments, and we have that we have currently deployed or are in the pipeline, and these will lead to significant leaps forward with regards to safety, efficiency, predictability, and of course, increased production. Now, finally, one very important point here is nowhere has it been possible to reach where nobody else has gone before without encountering some failures. So while we continue to embark on this journey of increasing our dependence and on technology and automation, and enhancing our oil and gas exploration with the helps of these, we need to understand that we will have setbacks on the way. Now, what is important is to continuously improve on the learning curve and be able to not make the same mistakes again and again. And then, hopefully we'll be able to achieve our targets with regards to the net zero commitments we have towards the planet, along with the increased production and the reduction of the operational costs. Thanks. Thank you.